In the previous lesson, we talked about what a shard key is. Now we're going to talk about what makes a good shard key. First, let's recap. You enable sharding at the database level. You shard collections. Enabling sharding on a database does not automatically shard the collections in that database. And you can have both sharded and unsharded collections in the same database. Not all collections need to be equal. First, let's talk about choosing a shard key that provides good write distribution. These are the three basic properties here: the cardinality of the shard key values, the frequency of the shard key values, and whether or not the shard key increases or decreases monotonically. We're going to go over each of these one by one. The first is that the chosen shard key should have high cardinality. Cardinality is the measure of the number of elements within a set of values. In context of the shard key, it is the number of unique possible shard key values. This is important for two reasons. The first is that if your shard key supports a small number of unique possible values, then that constrains the number of shards you can have in your cluster. Remember, chunks define boundaries based on shard key values, and a unique value can only exist on one chunk. Let's say we shard on a field whose values are the number of states in the United States of America. That's 50 states, so 50 possible values, and an upper limit of 50 chunks, and therefore 50 shards. That's quite good, but imagine if we instead sharded on the days of the week. Now we're down to 7 shards. What if we happened to pick a shard key that was a Boolean? Now we're down to 2 shards. Having higher cardinality gives you more chunks, and with more chunks, the number of shards can also grow, not restraining your ability to grow the cluster. I mentioned 2 reasons earlier. The second reason is actually related to our next property. The frequency of a shard key represents how often a unique value occurs in the data. Going back to our states example, imagine if we have a workload where 90% of the time we're inserting documents where the state is New York. That means 90% of our data is going to end up in the chunk whose range includes New York. That's not good. Remember that a chunk lives in a single shard, so now 90% of our writes are going to this one chart that has that one chunk. That's pretty severe hotspotting, and it's not what we want. Remember the cardinality property? Even though the values for possible states had high cardinality, our workload has high frequency, leading to bad performance. If our workload has low frequency of the possible shard key values, then the overall distribution is going to be more even. Now, if I have a very low frequency shard key combined with very low cardinality, like days of the week, I'm still potentially going to have problems. So the two of these properties work very closely together. Finally, we have to consider whether or not the shard is monotonically changing. Monotonically changing here means that the possible shard key values for a new document changes at a steady and predictable rate. Think of a field that has numeric progression. Timestamps or dates, for example, are monotonically increasing. Similarly, a stopwatch timer is a monotonically decreasing value. Why is this a problem? Remember that MongoDB splits your documents into chunks of data, each chunk having an inclusive lower bound and an exclusive upper bound of shard key values. All documents that fall into the range of a chunk are stored in that chunk. If all of your new documents have a higher shard key value than the previous one, then they're all going to end up in that one chunk that contains the upper boundary of your possible shard key values. So even though timestamps are technically very high cardinality, lots of unique values, and very low frequency, nearly no repetition of those unique values, it ends up being a pretty bad shard key. Fun fact, the object ID data type is actually monotonically increasing. That's why sharding on the ID field isn't a good idea. There are some tricks for achieving even distribution of monotonically changing shard keys, and we're going to talk about that in a later lesson. The ideal shard key provides good distribution of its possible values, have high cardinality, low frequency, and change non-monotonically. A shard key that can fulfill those properties is more likely to result in an even distribution of written data. Having a shard key that doesn't quite fulfill one of these properties doesn't guarantee bad distribution of data, but it's not going to help. So far we've talked about properties that allow for good write distribution, but there's one other thing to consider: read isolation. MongoDB can route queries that include the shard key to specific chunks whose range contains the specified shard key values. Going back to the states example, if my query includes state New York, MongoDB can direct my read to the shard that contains my data. These targeted queries are very fast because MongoDB only needs to check in with a single shard before returning results. When choosing a shard key, you should consider whether your choice supports the queries you run most often. Now, it's possible that the fields you query on make for pretty bad shard keys. In that case, consider specifying a compound index as the underlying index for the shard key, where the extra field or fields help provide high cardinality, low frequency, or are themselves non-monotonically changing. So without the shard key to guide it, MongoDB has to ask every single shard to check if it has the data that we're looking for. These broadcast operations are scatter-gather operations and can be pretty slow. Let's go over some considerations of choosing a shard key. We've already talked about these, but I want to emphasize them. You cannot unshard a collection once sharded. You cannot update a shard key once you have sharded a collection. You cannot update the values for that shard key for any document in the collection. What that basically means is that your choice of shard key is final. Whenever possible, try to test your shard keys in a staging environment first before sharding in production environments. If you use the Mongo dump and Mongo restore utilities, you can dump, drop, and restore the collection, but that's non-trivial. So again, whenever possible, you really want to test in a staging environment where you can safely drop and restore the collection without impacting production workloads. Let's recap. Good shard keys provide even write distribution and, where possible, read isolation by supporting targeted queries. You want to consider the cardinality and frequency of the shard keys and avoid monotonically changing shard keys. Finally, really remember, unsharding a collection is hard. You really want to avoid it.